Zircon from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada and around the world. The problem that I have on the screen, it's a limit problem. It deals with calculus. And of course what it's saying is n approaches infinity. We have a numerator and a denominator, and we're going to go and try and find the limit of this particular problem. Well, the one thing about infinity you have to understand is infinity is not a real number. It's a number without bounds. It gets larger and larger and larger all the time. So we cannot perform operations with infinity excepting for the one rule that I'm going to state right here. Any number divided by infinity is equal to 0. Okay? So as we look at this, I could make my life a lot easier by getting all of both the numerator and the denominator under the same radical sign. The technique that I'm going to use to do that is to take the denominator and square it and then take the root of it. It's the same as taking 2 and square it, make it 4, and then taking the root of it. It doesn't change the value of the term, but what it does, it changes the format or the way it looks. Okay, so when I do that, after getting it on the radical sign, I could write both of these under the same radical sign. So I want to do that. And when we look at this, that's what I've done. I've taken the denominator and square it, take the root of it, and now I could go and write both the numerator and the denominator under the same radical sign. And then I'll take the limit on the inside too, and then we'll start to manipulate that so that we could actually get the limit value. When we look at this, I'm going to expand this out, this binomial in the denominator. I'm going to expand that out so that I could actually perform limits on it. And when I do that, the way that you expand the binomial by special product, you take the first term and you square it, you place it in the first position. You take the product, multiply both of these times 2, and you'll get the middle term. So 1 times n times 2 will give you 2n, and square the last term and place it in the last position. So that's basically what we have here. We have the same thing. I've taken the limit on the inside of this. So we still have a numerator and a denominator, and if I were to go and substitute infinity in here, I haven't really gotten rid of anything. I would still run into the same problem of operation with infinity in it. Right? So I have to perform another operation, and that brings into the view this particular statement that I have here. Any number divided by itself is equal to 1. So if you have infinity divided by itself, it's equal to 1. I'm going to look at both the numerator and denominator, and I'm going to pick out the highest power there is. In this case, the highest power is a square term, right? So it'll be n squared. And I'm going to divide each one of these terms by n squared. Now, terms are separated by minus and plus sign. So we have 2 in the numerator and 3 in the denominator. And I'm going to go and divide each one of them by n squared. And that's what I've done here. And I've basically n squared divided by n squared. Well, we know that will become 1. And that's the same situation with the denominator, the first term of it. This one here, we know operation when we substitute infinity for n, operation divided by infinity, any number divided by infinity will equal 0. So all of these will become 0. And this, I've substituted infinity for every place there was n, and you could see infinity divided by itself will give you 1. This one will become 0, this will become 1, this will become 0, and this will become 0. And this is what I have remaining right now. Right? So you could see that in the numerator I have 1, in the denominator I have 1. 1 divided by 1 is 1. Anything divided by itself is 1. Taking the root of 1 will give you 1. So the final step of this is to write the original problem and equal to its limit. And there it is. That's all there is to this this particular problem. It is a bit of a complicated problem, so you should review it a few times. I'm hoping that this helps with what you want to accomplish, and it was nice for you to view the video. Thank you very much. Bye bye.